So, okay, so this one is chapter 12. So in this chapter, we will learn these 4 things: how to design classes, how to design association, the impact of integrity constraints on design, and how to design operation. Okay, so the first one here is detailed design. Okay, so traditional detailed design consists of 4 main activities as highlighted. Here we have 4 main activities, which is the input, output, process, file, and DB structure. Okay, input is whatever we take or we receive from we receive for our diagram. Output is what we produce or what is the result. And then process, how we will convert the input into the output, and file and DB structure. Okay, DB structure. And then here, traditional detail design tried to maximize cohesion. So I think in your previous chapter, I think in other course too, you learn about cohesion. So what is cohesion? Can anyone tell me what is cohesion? What is cohesion? Hmm. Farrow Vincent, what is cohesion? I think I remember this. This one asked in your SE software engineering course too. Farrow Vincent, what is cohesion? Jeremiah, what is cohesion? Wong, what is cohesion? Celine, what is cohesion? Can anyone, or Noel, is he here? Oh, Noel is not here. Student, what is cohesion? Any one of you can explain what is cohesion before we continue? Cohesion is what? Okay. Wait. Noel, no electric. Oh, be with my screen. So cohesion, close relationship, how model are related. How models are related, no electric. Close relationship of a model, how model are related. Yeah, we have to answer here by Jeremiah. Close relationship of a model and how model are related. This one is general definition, okay? It's like how they are related or to each other. Okay, so cohesion. Yeah, that's the more or less the definition of cohesion. So here, elements of module of code all contribute to the achievement of a single function. So cohesion is actually used to indicate the degree to which a class has a single, okay? The class has a single, or they have their own purpose. Each of the class have or should have their own single or a focus purpose, okay? So here, elements of module of code all contribute to the achievement of a single function. Single function here is referring to the single purpose or single function of a class. Okay. Here, traditional detail design try to minimize coupling. So what is coupling again? What is coupling? Coupling is referred to what? Anyone tell me coupling is referred to what? They try to minimize. So why do you think they need to minimize the coupling? What is independence of module? Yeah, independence of module. Like class should be independent. They should be independent. Of course, for a whole system, for example, for a whole system, in a system. So for example, we have, in a system, we have, let's say, 5 module. 5 module. Okay, let's say we have module A, module B, module C, module D, and module E. So not only traditional, actually, even in current practice too, we should minimize coupling. Okay, for some case, we cannot avoid coupling, but as a programmer, we try to minimize as possible. Why? Because each of the module should be, here the term here is independent. Okay, they shouldn't be depend too much on other modules. So here, unnecessary linkage between module that make them difficult to maintain or use in isolation from other module. So here, as you can see here, difficult, can I highlight? Okay, difficult to maintain. Why? Because actually, when we have like I said, for example, we have a system A and we have 5 different modules. So for example, we have bug. Let's say bug or new requirement under module A. Okay, so for some case, it's not for some case. For a system, of course, there will be a link between these 5 module. Okay, so what we can do is try to minimize as we can, so that, for example, we have, like I mentioned, it's no bug, yeah, bug or additional requirement. When we want to touch on the code for module A, just now, it shouldn't affect the module B, C, D, and E. Okay, so it is very difficult. It is very difficult actually if we have high coupling. That means each of the module is dependent. They are, yeah, they are linked to each other. Okay, so not only through traditional actually. This is what we should do. Okay, because it is difficult to maintain, not only to maintain some, not only to maintain, also to make any change or any enhancement to the code. Okay, so object-oriented detail design add, okay, details to the analysis model. Okay, so here as you can see, we have around add details. So the first one is attribute. Okay, you know what is attribute from our, you know, I think around 2 students is not here. 3. It's okay. So here, type of attribute. You should know what is attribute already. Okay, in our class diagram, and then operation signature. Okay, the key here actually, the operation signature. What they should do, what they should perform. Okay, and then assigning responsibility as operation. Okay, this one is more or less with the same with the second point. Here, assign responsibility as operation. So, for example, the module or the class, they should have their own operation. Okay, this one. Next is additional class to handle UI, user interface. Okay, for some, it's not for some, but sometimes when we talk about UI, UI sounds like it's one easy concept, but actually when we go into UI, actually it is not that easy because, yeah, we have an expert actually for UI. So for, even when you go to website, you can see if they have a good UI UX or not. Okay, so this one is very crucial actually. That's why they plug this subject or this term under OOAD, because they are related as well. And then next, handle data management. Data management, if I'm not mistaken, yeah, it's on the next chapter, data management. Okay, and then reusable components. So what is reusable components? I think from the term here, reusable components. Can anyone guess what is it mean by reusable components before I explain what is this term? What is here reusable components? Ian, since you are the last one here, so what do you think? What is the reusable components, Ian? Jonathan, Ian. Uh, I have the code into parts so that can be included parts of function. Parts of function. Reusable components. So here, Copy paste code. No, we don't copy paste code. No. So here, let me answer Jonathan first. So divide the code into parts so that it can be included in other part. This one is actually right. When we set reusable components, okay, first I don't want to confuse you guys. Reusable components, the basic definition of reusable components, okay, without touching on the programming part, reusable components is actually we reuse back the components that we already there. That's mean the here, uh, yes, basically reuse. Okay, the component is already there. Okay, that is the concept of reusable components. However, since you guys mentioned about the code here, so in a code, reusable components, or usually we have like function. I believe you guys what is function. So reusable components is more or less we call back the function. That's mean for that one particular function, we have a specific task they need to do. Of course, okay. So every time you want to use back that function, so we just call back the function. That one is in programming. However, in OOAD, reusable components mean we basically reuse back the existing components. Okay. For example, we have component A that we need to use back that component in maybe in module B. So we just call back that component in module B as well. Like superclass method or variable. Superclass. What do you mean here by superclass, Kelvin Shock? Superclass. Superclass is the, or just a module. Yeah, just a module. Superclass is like our, you mean inheritance? Is it? Inheritance, oh yeah. No, no. If you mean here superclass and you're referring to inheritance, no, that's mean here the basic concept of reusable components is like mentioned by Jonathan, basically reuse. Okay, don't confuse with programming wise. But in programming wise, yeah, we just call that the function. And then we assign class to package. So what is package? Package, I already explained so many times. Package is like we grouping our class. So however, we cannot randomly group the class into a package. Okay, cannot. There must be some common attribute, something that they have in common. So usually they have attribute. Okay, assigning class. We like group package. We sign the class into a package, or like we are grouping them. Okay, so this is a class specification attribute. So an attribute, as you can see here, we have a syntax here on how we write them, the rules. So an attribute's data type is declared in UML using the following syntax. So this is the rule when we want to write a, it's not when we want to write, when we want to write attribute. Okay, so here this is, I think we have explanation. So here name, so as you can see here we have explanation here. So this one is like, no, this is not function. So this one, the name here is referring to the name of our attribute. Okay, name here up here is referring to the name of our attribute. And then type of expression is its data type. Okay, data type. I think you know what is data type, any data type. And then initial value is the attribute is set when the object is first created. Okay, initial value. Like when, no, initial value, that means we set the, it's not variable. We set the initial value to the attribute, okay, when it is created. Initial value. And then property string described as property of the attribute, such as it can be constant or fixed. This one in here. Okay. So again, the name of the attribute, type of expression is the data type. There are few data type. You should know. Initial value. This one is like we set the value to, when we create this object, we will set an initial value. Okay. And then property string, constant or fixed. Okay, this one, this table you will see, I think around 2 or 3 times in this lecture. So Okay. So here we have a bank account class. Oh, it's already stated here. Bank account class with the attribute data type included. Okay. So this one is the attribute and operation. Class name, attribute, and operation. So here, as you can see, they highlighted here. Bank account class with the attribute data type included. Yeah. So can any of you tell me maybe one or two data type that you think in here in the attribute here? What is the data type included in this attribute? Any of them? Is it there or is it none? Here in the next account number attribute, bank account attribute, is there any data type that you can spot in the attribute? Yes, string integer. Yeah, string integer. Okay, and then if you okay, correct, Alvin. Okay, we have string and integer here, so I expect you guys know that too, because that one is basic in programming. So here we have shows a derived attribute. So I remember last week we have covered this one and I explained what is derived attribute. This one is under one model. What are the model name? I forgot what the model name, but I remember I explained about LSD. LSD, derived. So I remember I explained about this derived attribute. What is derived? What is derived, guys? Since this is new. Since this is new, so let me explain again. So derived, like I mentioned last week, we have an object. So derived is like an object, derived object or derived attribute. Sorry. Here it's referring to derived attribute. So last week I remember it's about derived object, but the concept is same. Okay, last week is on object, this week is on attribute, but the concept is same. Derived. That's mean we have this one here referring to the attribute, right? So we have this basic, if I'm not mistaken, the term basic attribute. So from that basic attribute, we come with a derived attribute. Okay, derived. Yeah, I do not know how to explain really what's the term derived. You can try to Google. That means we come. This attribute is come from a basic, base or basic. I don't remember the term, but yeah, it's come from an attribute. Okay, I forgot the term. Base or basic. Okay, however, this is the class specification of attribute. Okay, we will see that diagram again later in this slide. And then here we have this one. Okay, the attribute balance. The attribute balance in a bank account class might be declared with an initial value of 0 using the syntax. Okay, like I mentioned in I think slide number 6 just now, initial. Okay, initial, that's mean we assign a value to the to our attribute when we created them. So here we assign to 0. Okay, when we created this attribute, we assign to 0. Okay, we assign to 0. Initial value. Sorry, we assign the to initial value. Initial value of 0. Okay, so this one is our attribute balance, money, and 0. So here is another way. If the attribute may not be null, not, may not be null. Okay, not null. That means it's not null is empty. Null 0. Null, yeah. No value. So not null. Okay. And then arrays. Arrays are specified. As you can see here, qualification 0 to 10. This one is the symbol of array. So I won't ask what is array. However, array is a collection of element with the same data type. Okay, so I'm not sure qualification here is referring to what, but if qualification using the integer, so the data in the array should be the same data type. They should be integer. Okay, so arrays are specified. Okay, collection of an element. And then next we have too small. And then the syntax use of an operation. Okay, just now we have an attribute. Now we move to operation. Okay, so this one is the syntax. Okay, so like the attribute just now we have attribute name. So here we have an operation name. Okay, operation name. I think we have example. Where did I submit operation? No, we don't have the example. But this is the syntax. Okay, operation name, parameter list, and this one is equal to return type expression. Okay, so an operation's signature is determined by the operation name. Okay, the number and type of its parameter and the type of the return value, if any. So this point here is actually they make in a statement. So this syntax or the element in the syntax used for operation is actually explained down here, but they don't have example like attribute just now. So this one is the syntax of an operation. Okay, so we have few terms that I highlighted here and still under the operation. So only shows constructor where they have special significance. So get operation here. Okay, get operation to get the value of an attribute, also named accessor. Okay, accessor, that means we will get this value. This get operation also known as accessor. If you go to Google, I forgot already what's the term they define in Google. Accessor, that means they will capture the value. And then set operation. So operation to set the value, okay, or known as mutator. So what mutator do or set operation, that's meaning we will assign. Yeah, we will assign. So here we will assign or we will set the value to the attribute. Okay, set the value of an attribute. We assign the value to the attribute. And then varying levels of details at different stage in development cycle. Okay, development cycle here. Development cycle, varying levels in details at different stage in the development cycle. Development. This one is referring into the analysis, design, implementation. This one is in development cycle. Yeah, development cycle. Varying levels, that means they have different level of detail at different stage of development. That means when we are already code the program, when we are coding the program. Okay, so here the same diagram, like I mentioned just now. So here, actually the same page 11, right? Page 11, you can refer to the page 9 or page 7 just now. So shows a derived attribute, same like the one just now, attribute, derived attribute. That means we get this attribute or this attribute come from a base or basic attribute. Okay, and then bank account class with the attribute data type included. Okay, this one is the exact same one with the one just now. This one is the new one, explanation. Okay, so here we are using the bank account class, and then we have the attribute here, and this one is the operation. Okay, even without this, what is this? Remark here, I think you should know this one is the class attribute, and this one is our operation. So this one, bank account class with operation signature included. If I'm not mistaken, in this slide I mentioned operation signature should refer to the function or the task of that specific module or even class. Okay, so this is the explanation. This is the example here. Bank account with operation signature. So yeah, I should ask, can any one of you tell me if there is any operation here and under this attribute? There's actually many, but yeah, can you give me what is the operation here under this attribute? 3, 4, 5, 6. I think around 10. Alvin, since you're the last one. Alvin, what do you think? Can you give me one example of the operation? Or what is operation actually? Alvin, Tin, Kaseng, Alvin. What is the operation? Can you give me, I won't ask you what is the operation, I will explain, but I want to ask you, is there any operation that will be performed under this bank account? Farah Vincent, what do you think, Farah Vincent? Or Ivan? Oh, Farah Vincent is not here. Oh, Farah Vincent is not here. Ivan, what do you think, Ivan? Lim, what do you think, Lim? If not Lim, who is that good boy last week in the presentation of RM together with Jonathan Ian? I think, let me check his name. Uh, 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 uh. I think it's Jeremiah. Yeah, Jeremiah. Open? No, my question. Oh, wicked. My question here, I asked if there is, of course there are, if there's any operation here in this operation signature here. I asked for one example. So here we have answer by Kelvin Shark, open account actually. So okay, like I said, operation is actually any task or any task, operation or function. Yeah, task, operation or function. So this term is actually referring to the same term, task, operation or function. That means they need to perform. Okay, so here in this under bank account class, we have operation signature here, which is mentioned by Kelvin, open. So here, that's mean open account. And then we have checking account status. Where's checking account status? Where's checking? Actually, the
No,
operation
never
is,
mind.
oh,
Yeah,
good job.
I
Oh,
understand.
yeah. Okay. So here the operation is here, open account name, close, maybe close account, and then credit, debit. I'm not sure credit, debit is in or out. Okay, but however, the process is credit and debit, and then view balance, and then get the balance, get account name, and get set account name. Okay, this is all the operation signature or task or function. This credit and debit, you go and Google. I'm not sure to which one is in, which one is out. Okay, that one is for operation signature. So before I move to this visibility, this one is an operator. So can I move, or is there any question? Okay, since I assume no, so I proceed. So here we are in patch 13 already. As you can see, we have this visibility. We have this visibility. Okay, so here in this lecture, there's no definition of visibility. However, the function of visibility is to allow to, what I'm writing here, constraint. I don't even understand my own handwriting here. The usage of name of the element. However, we will see later, there's an example here. Okay, so actually there are only 1, 2, 3, 4, four symbol that you need to learn for this visibility. So first, public. Okay, public. So the meaning of this public, when you have this in your attribute letter, okay, that means this particular attribute is open. Yeah, public is open, and it can be directly accessible by any instance of any class. Public. So if you see this operation or this symbol, that's mean, sorry, that's mean it is an open. Okay, an open operation or an attribute. And then private. Okay, private, that's mean this attribute or any operation can be only used by an instance, the class that includes it. Okay, So for now, if you don't understand, because we have example letter, so you just need to know this one. This one public, that means this one is open. Private, it's private, that means it's only accessed by the class. And then protected. So this feature may be used either by the class that included or by a subclass or descendant of that class. Okay, inheritance, and then package. So the feature is directly accessible by an instance of a class in the same package. So in the same package, like I mentioned just now, package is like grouping. So when we want to group, for example, any class or any element, we cannot randomly put them or pick them random in a group. There must be something that they have in common. Usually it can be attribute or any operation. Okay, public, open, private, limited. It's not limited, yeah, but exclusive. Yeah, that's the term I use. Protected, subclass or descendant. That's mean inheritance, and then package in the same group. In the same group. Okay. So here, this one is the example. Okay. This one is the example of one, two. However, we only see three of this. The private one, private is this one just now. I'm not sure if you can see, but but it's in yellow. So again, we are using bank account class. Okay, so we only use 1, 2, 3 here. Okay, this one is minus sign. That's mean this one is private. Okay, private. That's mean only this class can use. And then we have this one public. Like I mentioned just now, it is open. Okay, it can be accessed to any class by any class. And then this one is protected. Protected, if you go scroll above, this one is can you use by subclass. Okay, inheritance I mentioned just now. So this is how we use this visibility symbol in our diagram. So you should know actually what is it mean by this one, because later when you go to work, when people, even as a, of course, as a BA, you should know this thing too, because like I said, OOAD is for those who want to be a BA, but as a programmer too, you should know when you see this symbol. But of course, we have Google. So if you don't understand later, you can Google what is it mean. But in this diagram, we don't really use much operator. So this one actually is example bank account, next account integer. Okay, so here we apply the symbol. However, here we have in bank account, first bank account A, we only use two symbol, which is this one, like I mentioned, this one is private. Okay, private, and this one is open or public. Sorry, public. Okay, open. And then this one here in the account bank account B, bank account B, we have public, private, private, okay, exclusive. And then we have public, which is open, and we have this protected operation. Oh, it's already here already. And protected operation, okay. This one is the example. Class scope attribute, this one, private attribute, pointing to this one, same actually. Derived attribute, okay, we have this symbol here, derived, that's mean it's not inherit. Derived is not inherit. Derived, we come this attribute actually from a basic or best attribute. And then class scope operation, this one for operation, and public, again public, open, private, that means this one is exclusive. This one same actually, exclusive, private, and protected. Protected operation, that means this one can be used by subclass. Okay, so bank account class with alternative visibility specification. So alternative visibility specification is referring to the use of this symbol, operator. Minus, plus, or private, public, protected, and there's one more package. They are using only three here. There are one more package. Okay, so this is the example. Okay, so that one is for visibility. So for visibility, what you need to know, of course, the use of the, or the meaning actually, the meaning or the use of the operator. Is it operator? I use operator. Symbol. Sorry, not operator. Symbol. Okay, usually we will see that one in our document. So now we have interface. Okay, so what is interface? Interface is what we see. What we see, user interface. Yeah, user interface. Since you guys have this HCI subject, I won't explain more, but however, interface is what we see on our screen, the how the user want to interact with our system. Okay, UML support two notation to show interface. Okay, two notation to show interface, to display the interface. So the small circle icon showing no detail, this one here. We have an example next slide. So the small circle icon showing no detail, a stereotype class icon with a list of the operations supported, and normally one of these is used on a diagram. Next diagram. So again, the realized relationship represented by the dash line with a triangle arrowhead. Okay, dash line with a triangle arrowhead. Arrowhead. Arrowhead indicate that the client class advert support at least the operation listed in the interface. So here we have 1, 2, 3, 4, 5 classes here. If not clear, I think you can refer to your lecture note. So we have 5 classes here. Okay, this one is interface, right? Let's look at the interface classes. Okay, this one is the use actually. For this, because I already checked this lecture note. So for page 16, slide number 16 and slide number 17 is actually showing the whole diagram, but the explanation is actually basic from this one. They only show what is the use of the notation. Okay, this diagram is not new to you guys. However, this I'm pretty sure this diagram is not new to you guys. You should know already by this week. I mean week 13, you should know how to read the relationship, for example, from this one to this one. What is the relationship? But the difference is only on the use of notation. Okay, yeah, the use of notation. So you can cross check actually from this one to this one. Okay, so that one is for UI. There's nothing much actually on UI. Same with the visibility. You should know actually what is the use of the notation and the symbol. And then we have association. So association 2 is not some, we already learned association. But what is association? What is association? We won't touch on the concept of association in this chapter. However, we learn on how to design the association. But I want to ask, before we move to learn how to design the association, I want to ask, what is the concept of association? Okay, never mind, I will tell. Association is a group that we link together. So that we link together. Usually this group this group have something that in common. They have something in common. For example, it can be their structure or it can be their behavior. Okay, so here an association that has to support message passing. So message passing, you know already, message passing is the way or is a platform. It's not a platform. It is how they are communicate each other. It's a method of communication between the class. Okay. So an association that has to support message passing in both direction is a two-way association. Okay, here the keyword is two-way association in both direction. That means from class A they can go to class B and class B they can go to class A. That one is two-way association. Okay, so here is the keyword actually arrowheads at both ends. Okay, we will see step by step. If I'm not mistaken, we will see step by step. So this two-way association is indicated with arrowhead at both ends. Okay, that one is two-way. Like I said, from maybe class A to class B, class B to class A, two-way. So minimize the number of two-way association, keeps the coupling between objects as low as possible. Again, minimize the number of two-way association. Keep the coupling between the object as low as possible. Coupling, I think I already asked. Okay, this one is, like I said, step by step. Okay, so before we go to two-way, we should know this one term, one-way. One-way, one-to-one association. Still in designing association, so we have this class owner and car, as well as the attribute, okay, owner and car. So a row head shows the direction in which message can be sent. Yeah, if I'm not mistaken, even in your assignment, if I am not mistaken, in initial diagram, the last diagram, you have something like a diagram. However, in the assignment, it is not in the requirement for the student to state what is the relationship or the association between the class, but I ask you guys to to write in point actually what is the association, because I want you guys to know or to learn how to read the association. So here, owner on one car, owner owns one car. So the arrowhead here referring to the direction, okay? Direction, the message can be sent. This one, however, this one is not two-way, because if you go and scroll at slide number 18, two ways, that means there are two arrowhead. We will see later. So this one is one way. Okay, one-to-one association, one way. There's no arrow here. It's only here. One way. Arrowhead shows the direction. Okay. This one too, this one is, yeah. I want to ask you guys, is this in, not clear, right? Is this one way or two way? Creative staff and campaign, is it one way or two way association? If you do not know how to see, you can scroll back. I think slide number 18. Yes, Jonathan and Kelvin Shark, Farrell Vincent. To solve many-to-many relationship between entities. To solve many-to-many relationships. To solve many-to-many. Did I miss out anything? But yeah, the here is actually two ways. How you know it is two ways? Because because two ways. In page 18, I explained we can have two arrowhead at both sides. Both sides how? This one, one. This one, one. So we have two at both arrow side. Both arrow side. Both side actually. Okay, so how to read campaign? We can have one creative star. So they will send. So the arrow here is referring, same with this one actually, shows the direction in which message can be sent. So we can send message from campaign, we can send message to creative staff, and creative staff too can can send message to this class. Okay, and then you can see the use of this symbol again. Aggregation. Aggregation. Okay, so this one is the example. I want to explain each of these. What is the attribute of this class? You can see, I want to explain what is the attribute of this campaign or what is the process for each of this class. But the point here is this two-way. Okay, that means this one can send to this one and this one can send to this one. For this one, campaign can send message to this advert or to this class. Okay, the direction of a message that can be sent. And then, is there any question for that one? Do you understand the one-way and two-way association? So one-way is it's easy. Yeah, it's quite easy actually. I don't want to say it's easy, but it's quite easy. You just see at the arrowhead in which direction. Okay, the direction pointing to the message that can be sent. So here, collection classes. Again, message passing, we have this term here. So I mentioned just now, message passing is the way we it's not we, the class used to communicate. Okay, they have it can be a request, it can be a response. But however, that's how they communicate between the class. So collection classes are used to hold the object identifier when message passing is required from one to many along the association. Guys, 1 minute. Okay, sorry. So collection classes. And then OO, object-oriented language, provides support for this requirement. So frequently the collection may be implemented as part of the sending classes, for example, campaign, as some form of list. So here sending classes, example campaign, you can look at here, sending classes campaign. Okay. Yeah. So collection class, as mentioned here, it used to hold the object identifier. Okay, this one is the sending classes campaign, and then they send to advert collection. Okay, so this one is they are holding the object identifier, and then this one, if I'm not mistaken, yeah. Okay, designing association, and then let's move to the next slide again. Campaign, which is our uh, mm, guys, I think we should have, can we have like 5 minute break? We will continue at 11:01. So hi again. So let's continue. So just now we stopped at these two association, right? At yeah, designing association. Okay, for collection classes. So this is the example. Okay, this one is the example. Okay, however, this one is not no, this is complete already. So this is a design example of our diagram which use one way or one to many association using a collection class. Okay, so before you know this one, the new thing here is only the term here, collection class. So the collection class is referring to this one. So collection class are used to hold the object identifier when message passing is required from one to many along an association. Okay. And then this one is the example of a object class just now, right? Yeah, collection classes. Okay. So here again, one way, one to many association. One way, one way. Okay, one direction. One to many, one direction. Yeah, one direction. One to many association using a collection class. One direction. Okay, so here SD for list advert. So this one, this diagram too is not something new to you guys. You even have this diagram in your assignment. Yeah. So this one is the class just now. Okay, I want to explain how to read this optional loop or this SD diagram here. However, it is this class campaign, advert, and advert. This one is actually from this one, the diagram up here. Okay, so this is the SD diagram from the diagram above. Like I mentioned, this one you should know already how to do this one. So the sequence diagram shows the interaction when using a collection of class. Oh, cannot highlight. Yeah, when using a collection of class, this one on advert size and on advert size. Okay, and then here is example of two-way many association. Why it is two-way even though you only see here one arrowhead, one diagram. Yeah, this one is okay. This one is the example of two-way, but why two-way even though you only have one direction here? It will explain by the next slide, the next step by step. So this is the design for the works on campaign association. Okay, we have this creative staff, campaign collection, campaign and staff collection. Okay, so how to design this one? So this one. So this one is like a sequence actually. So two-way many to many association. So we have creative staff and campaign. Okay, creative staff and campaign here. Creative staff and campaign. So this is a two-way many to many. Why two-way? Actually, they have like some class in the middle, but two-way is from this one. And many to many association or multiplicity. Okay, so from like I said, it is step by step. So from these two classes, we come out with this one. Okay, a class, like I said, there's some middle class. It's not middle, there's some class in the middle. So we have this staff collection with campaign staff attribute. So they already break the what is now the arrow to two direction. Okay, the two direction arrow just now from creative staff to campaign only. So now we have this class at the middle, staff collection or campaign staff attribute. And then from this diagram, we have another diagram, which is this one. Not diagram, sorry. Another class, which is campaign collection. Okay, like I said, the initial one, we only have this creative staff and campaign, which is two direction. which is two direction now. And then after these two class, just now we have this class staff collection, and now we have this campaign collection. Okay, you can see the clear, like it's not the clear, it's like a clearer association. And then from actually, yeah, and then from the diagram just now we have this, what is this, the association between this class creative staff and campaign collection. Yeah, these four classes. Okay, so that's why I said this now, two-way, but how it can be two-way even though you only see this one, actually two-way association. So actually from this two-way you can have something in the middle here. That's why it's like breaking. It's not breaking. What the term? It's not breaking. Adding. I'm not sure what's the term. However, this is a clear the exact diagram actually. So that's why when you have creative stuff and campaign, you can see two ways, many to many association. Two ways is referring to the direction. I repeat two ways just now, like explain two ways or one way. It's not only two way. One way or two way is referring to the direction that the message can be sent. So here in creative stuff, this class can send a message and this class can receive a message too. Okay, two-way many association. So if one way, that means from one class they can only send or they can only receive one message passing. Here, as you can see, it can send, it can receive. It receive the message, actually, the message passing. Okay, so this one is a clearer example, clearer diagram. Compare. It's not compare because this one is a step by step. Okay, so this one is the final diagram actually. No, the term is not final diagram, however, final step. Here's of the two-way. This one is a diagram. I don't want to explain this one. It's not I don't want to explain this one. We'll discuss this one in our next class. And then here we will move to integrity constraint. Okay, so integrity constraint. So actually the definition here is integrity. So integrity is actually if you Google the term, right, I don't think you can apply that in OOAD. So let's stick to this slide here. So integrity constraints, referential integrity that ensure that an object identifier in an object is actually referring to this keyword here. The keyword is here, object that exists. Okay. Okay, referential integrity. That object that we're referring to must be exist. Okay, so dependency constraints that ensure that attribute dependency, where one attribute may be calculated from other attribute, are maintained consistently. And then domain integrity that ensure that attribute only hold permissible value. Okay, integrity, the term integrity is actually referring to quality of being honest. So here in OOAD, it's actually the quality that, of course, first the object must be exist, and exist, and then the domain integrity need to hold only the permissible value. Okay. So here in this slide, constraints again between association. I check your attendance. So constraints between association. Okay, association again. And then here we have committee and employee class. So here constraints here is referring to it's not restricted. Okay, here as you can see, we have committee and employee. So this, if you refer back to slide number 31, the class actually must be the integrity, right? The term yeah, integrity constraints. The class must be actually pointing to the exist object that exists. Okay. Actually, if you are, how to explain this? If you're referring to this one, this slide here, maybe you won't understand. But I think if I give you guys like example, hmm, let me think. Um, should I example? For example, when you want to draw a, for example, when you want to draw like object that exists. No, I shouldn't give that example. However, just stick with this one, integrity constraint. That's mean whatever diagram or anything that you want to uh, put as an identifier, you must put an it's not exact. That object that you're pointing to or you're referring to must be exist. Okay. I won't give you example. So here is constraints between the association. Okay. Here subset of. That's mean they have or they are pointing to this object. To the no. Wait. Referential object identifier. This object is exist. So this one is actually referential integrity. Referential integrity. This one is exists. This one, as you can see, this one is exists. So this one is employee. How should I explain this? Maintain consistently. Why do you have to have this diagram here? Dependency constraints. Dependency calculated. Actually, this second point here, dependency constraints. This second point here is actually referring to this arrow here. The relationship between two, it's not relationship. Attribute and where an attribute may be calculated from other attribute. Actually, the second diagram here is from the second point. The first and third diagram is only explaining the concept. So I leave this part for you guys to read. I'm not sure to how to explain this part because actually they should remove this one. Okay. This one is straightforward actually, the second point with the diagram here. So I leave this part, second part. It's like you don't need to understand. You just need, of course you need to understand. I mean, you just need to cross check between the second point and this slide here. Slide number 32. Okay, I leave this part for you guys to read. Suddenly I become blur. And then next, designing operation. So like I mentioned, operation is any task. I mentioned three terms just now: task, operation, and function. They are more or less the same. So designing operation. So various factors, constraint, algorithm. Algorithm, you should know what is algorithm design. Okay, so in operation, it is very common actually. We have an algorithm. Not all, but yes, usually we will have this algorithm. Hmm. Okay, if you guys remember, if you attend last talk last week, last Saturday, if I'm not mistaken, a talk by Miss Fatin Nabila. Miss Fatin Nabila, I forgot her name. She mentioned about the job. She mentioned about data scientist. So I I don't remember if I mentioned about data scientist with your class. However, mm, programmer, as a programmer, we don't really produce. It's not produce. We don't really design the algorithm. Okay. The people that will design the algorithm will usually be the data scientists. Okay. They will come up with the algorithm that tackle the requirement. So we just get the algorithm from the data scientist. We don't develop that algorithm. We will only use the algorithm that suggested already by the data scientist. So in algorithm, I'm not really sure too how those people or how the data scientists will perform or they will come out. I'm not sure. I never involved. But programmer, we only capture what they ask us to do based on the algorithm. We don't design. So here various factors, constraints, algorithm design. Algorithm design. So the cost of implementation. Okay, so if I don't think here. Okay, let me explain. This one cost of implementation um sometimes when we want, it's not we, the data scientists, they want to design their algorithm, right? They need to have tools, specific tools. Maybe I can't give you example because I do not know any specific tools that they use for analyze data for, but I'm very sure mm, they need to use any specific tools, or even sometimes they need to outsource. Okay, so to look for what's the term, for the people who can really or know how to use the algorithm. So the cost of implementation. Okay. Sometimes the data scientists themselves, they need to seek help from other experts as well. So they need to include them. The cost of implementation, or how does it will affect the system. Yeah, how does it will affect the system if they implement the algorithms? Well, they reduce the value of our system or not. And then performance constraint. Performance, I think you know what is performance. Performance is referring to the performance of our system, of course. So by using this algorithm, can they increase the performance, or will it affect the performance? Or can it really deliver the requirement that we want it to be have in our system? And then requirement for accuracy. Okay. Mm, okay. So for a student, it's not for a student. A requirement for accuracy. I think I mentioned, I'm not sure if I mentioned in this class. So we can deliver a system, we can deliver or develop a system. But is it the system that we deliver, or is it the system that we design is accurate with the requirement? Okay, so we need to really understand what is the requirement of the system, and we need to design algorithm that really deliver the requirement. But like I said, not all system will have algorithm. But I know there are a system who is not, it's not who, which is not really complicated, simple system that doesn't need any algorithm. And then the capabilities of the implementation platform. Okay, implementation platform. Here referring to if we already have this one system already designed, developed, one complete system already. So we need to think to actually before we design, we need to think what is the capability of our system to be implemented when they're already in the environment. Implementation platform is referring to the environment where we want to deploy our system. So we need to think this one too. But usually for algorithm, they don't really, no, like I said, for me as a programmer, I don't see, I'm not sure for data scientists, I don't see really how the algorithm that they produce or how the algorithm that they design need to concern with the implementation platform. However, this is the factor. If you ask me regarding the logic that I have as a programmer, I cannot relate with this one. But these three, yes, it is obvious. These three implementation platform, I'm not really sure. I cannot give you example on that one. Okay, and then operation, designing operation. So, oh, the last page. Okay, designing operation. So factors that should be considered when choosing among alternative algorithm design. First here is computational complexity. Okay, this one is computational complexity is referring, the term here is complexity. However, I think every algorithm, I'm not sure the data scientist, but I have a, of course I am a programmer. I have like a, it's not we work together, but for, yeah, I'm not sure, but for computational complexity, of course, when they are designing the algorithm, here they need to reduce or they need to tackle the less complex algorithm. But sometimes, again, not only for algorithm, even for our diagram, we cannot avoid our complexity to deliver our system, to deliver the requirement. Okay, here is computational complexity. And then ease of implementation and understandability. Ease of implementation, like I mentioned just now, I cannot really relate, or I cannot see what is the logic between the algorithm, but the point is here ease of implementation. But understandability, this one I can relate. Why? Because, like I said, when we, as a programmer, actually, when we are writing a code or a program, it's not that we write only, like we only write the code. We need to understand what is the logic. What, yeah, usually we will use the term logic. So we need to understand what is the logic of the algorithm in order for us to write the code. Because the data scientists, they will only show you, like they will only explain to you what is the algorithm, but they don't explain to you how to code it. So you need to understand. So ease of understandability, easy for people to understand. And then flexibility. Flexibility is adaptation. No, it's not adaptation. It's the flexibility if there's any changement. Any changement. If there's any change, okay, if they want to change anything on the requirement, yeah, they will change the flexibility. They need to change back the algorithm. Okay, fine tuning in the object models. However, fine tuning is not something specific term in OOAD. Fine tuning, that means they need to be like sync, if I'm not mistaken, the term sync with the object model. Okay, so this one is more to algorithm, and then that's the end for our chapter 12. So here, summary. In this lecture, you have learned about criteria for good design, association, integrity constraint, and how to design operation. Okay, especially for the last term here, I can't really relate algorithm because I don't really design algorithm. This is my weakness, algorithm. Okay, so that one is for chapter 12. Yeah, correct, chapter 12. So we have one more chapter, which is data management design. Okay, before I move to chapter 13, chapter 13, correct, only 32. I already mentioned we have like 32 slides. So actually I plan to, yeah, can we proceed to chapter 13? Can we proceed to chapter 13? Okay. Okay. So data management design. This chapter 2, we have no diagram need to be learned. This is a concept. Okay. So data management design. Yeah. So in this lecture, you will learn on several object persistent format, and then be able to map problem domain object to different object persistent format. I think this term is a new term for you. Map. It's not a new term. It's a new term for you in OOAD. And then be able to optimize a relational database for object storage and access. Be able to design the data access and manipulation classes. Okay, so here at the third point, you will see this term a lot, which is DBMS or DBMS. Okay, so here the data management layer. So data management layer, here we have a term DAM, data access and manipulation. Logic and the actual design of storage. So DAM here, data access and manipulation, is actually referring to the set of process and technologies to control the access to application or data. So it is a set of process and technologies, okay, and the actual design of the storage. Okay, so here, for step design approach and data management, data architecture, system software architecture. Have you ever heard or have you ever learned in other subject data architecture? In this chapter, in this subject, I don't think I mentioned about data architecture, system and software only, right, for this course. So in other subject, have you ever heard about data architecture? Data architecture, database data architecture or DB architecture. I don't think it's in this subject I mentioned about data architecture. Is there anywhere that you learn about data or Tansunyap Daniel? I think have, but I forgot. Data architecture, not in this course. I remember not in this course. However, the term I asked is not here in this slide. However, the data architecture is actually when we want to design a system. Okay, this is a logic where I combine the system and a DB. Okay, so when we want to design a system other than the system that we need to analyze, of course, but usually people as software engineer, we will focus on the system. Okay, but there is one more crucial, it's not one more, yeah, but database architecture is another crucial part when we want to design the system. Okay, so I forgot already what is the job name for these people, for this group. But usually the database architecture is referring on how we want to design our database. Okay, when you have, I'm not sure for your level how you learn DB, but for my level, I think it's quite easy DB. But actually, DB is quite complex, especially when you have a big system, complex system. Of course, it will come with a complex DB. So actually, when you want to design a DB, it is not only focusing on the what is the table name. It's not only focusing on what is the table name or the column name, table name, yeah, table name or the database name. Actually, DB architecture is another quite crucial. Why? So, for example, this one I can give you example. So, for example, have you ever think when you design a system? Have you ever think how how they mapping is how they map from the system to the DB? Okay, so for example, how do you know? I don't have any. For example, this is our system, right? How do you know this? Can you see? It's not how do you know. How the system know that, for example, this is my interface. This is a system, of course, okay? Staff intranet system. So have you guys ever think how this, for example, my username, right? For example, my username. How do you know the database will capture or how they map? Map is like, for example, username, they should have one. I'm not sure the DB for this stuff intranet. So how do you know, how the system know that this input that they key in here in this username field will map to which table or which column in our DB? Okay, that one what we call as mapping. Okay, so when people say mapping later, you should know that mapping is actually like when the user key in username or password, it should point to the direct column or direct table. Yeah, direct table. A correct column or correct table. That one is mapping. Okay, because what I remember last time as a student, I learned DB, but I do not know how to relate or how to connect or what is this mapping thing. So mapping is like we map the column in our interface with the with the database at the back end. This one is usually done by the full stack overflow. Full stack overflow. Full stack developer. Full stack developer. Okay. So if you remember again, mentioned by Miss Fatin last time, full stack developer, those who touch front end and back end. Okay. If you're only UI or front end designer, you won't see this thing. Okay. So here, 4-step design approach. So select the format of the storage. Okay, this one usually during the analysis, we need to select the type of the format for our storage. And then here the term that I highlight here is mapping. Mapping problem mapping problem domain object to object persistent format, and optimize the object persistent format and designing the access and manipulation. This one is the DAM just now. So DAM, like I said, it is actually a set of process and technology to control the access to the application or to our data. So, okay, we will go actually to each of these. So this one, the first one, okay, select the format of our storage, which is transition versus persistent. Okay, so transition versus persistent. Do I have? Oh, okay. So we have these two terms here, transient, transient and persistent. So what is transient? Okay, transient is actually any object, okay, any object or any data that it only available for a short time. That means it is only temporary. Okay, transient, temporary. The keyword for transient is temporary. So here, some objects are transient, temporary. So it is only exists in a memory and are discarded when an application terminated. So terminated, stop. Okay, so stop. Discarded, that means discard. You know discard, right? So they will be gone. Yeah, discarded. So it is only temporary. Okay, transient, the keyword is temporary. Okay, they will be only temporarily stored in memory, then they will be gone when it is terminated or stopped, when our application is stopped. Okay, and then here the next one, in persistent. So some object must exist from one execution of one application to another, or to be shared among different instances of application. So such objects are persistent objects. That means they are consistent in our memory. Okay, that means this kind of object will always, not will always. That means they will be keep or exist in our memory, even though they already terminate the application. So two terms here, like I mentioned, transient, temporary. Okay, temporary object, and persistent is the fixed. Fixed. Fixed, yeah. Let's say it is fixed. That mean it's already there in the memory. Okay. Temporary and fixed. Okay. So selecting the format of the storage object persistent format. First, file, sequential or random. I think we have example for this one. Okay. File, it is in sequential or it is in random. And then relational database. RDBMS, relational database, object relational database, or object oriented database. Okay. Next, yeah, this is actually example of, let me read. This one is banking too, if I'm not mistaken. Is it? Yeah. This one is banking DB too, because I capture few term there. Oh, this one is actually a database. Oh, it's not database. This one is actually a statement captured by the from the DB. However, here this one is for the banking application. It's not banking database. It's from banking database actually. This data here. Okay. That one is only an example. So selecting the format of the storage, like I mentioned just now, we have sequential or a random access. So sequential, even from the term, it is quite straightforward. Sequential, that means it is in order. Yeah, we have an example here. It is in order, and then random access file. Okay, so sequential access files allow sequential operation, which is read, write, and search. Okay, however, if you go to the If you go and you're familiar with DB, right? When you open the DB, when you open the back end, the database actually, you can see this term. This is, you should be familiar with this term, read, write. You guys learn database, right? What is it mean by read only? Sometimes they have three: read, write, read, and write. So what is read actually? What is read? If they say it is a read, then what is a read? Or if sometimes they say, they just put the initial R there, R, W, R, and W, if I'm not mistaken. View, read. Yeah. For R, I'm sorry, I mean read. For read in database, there's usually no read or R. They are actually the same. So read, that means the data can be only be view. The front end can only view the data. This one we will set actually at the back end, at the database. We will set if this table, for example, this, yeah, for example, the table, the user can only read, view, read without changing anything. Right? That means they can only key in the input. Okay, read, write, that means they can key in and then they can view, read and write. And search. Search is, this one is not rare, but usually you will only see these two. Read, write, W, R, W, R, W, and R and W. Sorry, R and W. Search is for searching function. Okay, so here this one is like an advantage actually. Okay, why we use sequential? It is efficient for writing because everything is in sequence. Okay, search are not efficient because an average of 50 of records have to be accessed. Why? Because everything is in sequence, so they will find, or they will search, like I mentioned, search function, so they will search everything in sequence. Okay, so they need to access all record. Okay, and then there are two versions for sequential here, ordered and unordered. So this one already asked, test yourself, ordered or unordered, A, B, G, H, K, M, N. So do you think this is ordered or unordered? We have two actually, yeah. The first one, is it ordered? What is the second one? So Celine and Jeremiah, what do you think? This one, the first one, is it ordered or unordered? And the second one too, here, is it ordered or unordered? I cannot highlight. So this one, ordered or unordered for the first one? Ivan, the first one is ordered or unordered? This one, yeah, the first one. Is it ordered or unordered? How do you know if it is ordered or unordered? So we have answer. So how you know it is ordered and unordered? So I think I mentioned just now, it is in sequence. Okay, so here we have record A, any record A, B, G, H, K, M, N. Okay, so this one is actually ordered. So for example, if we have name here in, so if let's say your name is in my database, do you think your name start from Ivan except my name? So do you think your name is ordered or unordered if this name we store in my DB? Your name, the participant here in this class, do you think it is ordered or unordered? Here, start from Ivan actually. From Ivan name up to Wong here, it is actually ordered actually. How you know? Because it is in sequence. Okay, A, B, G, H, K, M, N. The first one is obviously it's ordered, and then the second one is A in the middle. Of course, it is unordered. So how do you see this in DB? Usually in DB, we have type. It's not type. It is actually, usually we will go for this one. People will go for this one, A, B, G, H. No, no, no. No, I remember, no. No. Let me think. Some, because I'm only familiar with banking, right? So let me think. The database at the back. I forgot already. I take back what I said. It's not necessary. Usually this one. I forgot already. Yeah, I forgot. They usually have some ID, so usually people will be ordered with the Steve ID. Okay. So, however, that's the concept ordered and unordered. Okay. Select the format of the storage random access file. Okay. Random access file. Still in selecting the format of our storage. So here we have random access file. So they only allow random or direct file operation. Okay, random or direct file operation. Good for finding and update a specific object. Good for finding. Different with the just now, it is said that for search function it is not efficient. Okay, but inefficient for report writing. This one is contradict with the first one just now. For the first one just now, it is efficient for report writing, but it is not good for searching function. Here it is good for finding and inefficient. It's not inefficient for report writing. Why? Because they only go for random. They don't go in sequence. Okay. Here, selecting the type format of the storage application file type. We have 1, 2, 3, 4, 5 master file. So what is master file? I don't think it is explained here. However, master file is actually a file, okay, in our database. No, database. Yeah, in a database, usually we have this one term where we call it as a master file. So in this master file, this one, they won't keep the data. They won't keep, for example, the name of our client. I mean, the name of our student. Okay, they won't keep the name of our student. However, in the master file, they will have this something like, for example, in database A, we have this table A, we have this table B or table C. So they will store whatever the primary key, if you know primary key or foreign key. So they will keep in master file. Okay, they won't store the data of the customer or client in master file. They will store, yeah, something like what is the primary key, what is the foreign key. I think you know what is primary key. And then lookup file where we want to search for our data. Okay, and then transaction files. Transaction files is more or less like, oh, it's not log. I'm about to say log. Transaction file is actually, I think it will produce transaction. I never heard transaction file before. Transaction, I think it will store because we have this one here, history file or what we call as log file. This will actually store the everything that we have here into the history or the log file. We usually we will call log. And then audit file. Audit file is actually anything that we want to do. It's not anything. Any file that used to do, usually audit file is actually this file where we will check everything back. Okay. And then history file, like I said, transaction should go under history or the log file. The term here is history. It will actually stat. Yeah, it will show or stat or view actually any transaction or anything. Okay. Log or history file. So usually out of this one, the biggest size will go to this one. History file. Master file. Master file is not big, but master file is very important. However, it will go to history file. For some file, before I move, for some storage application, mm, for some storage application, when like I said, this one is big, right? When the storage already reach some limit, usually they will set limit. They will delete. It can be based on the size or it can be based on the time. They will remove, not remove. They will delete some of the file in history file, log or process in history file. Okay. And then this one too, this one exercise. I think this one is quite easy. So yeah, they don't ask you to draw. They ask you to identify. This one is quite easy. I won't explain this here. This one is, I will keep for next week maybe. So here again, selecting the format of the storage, which is relational database. Okay, so collection of table. You should know what is table, right? In DB. Table, table, table. You are familiar, right, with the term table? Yeah. You should know what is table. Table lol. Table is yeah. So I assume you know what is table. Okay, under DB we have table. Under table usually we have column. Okay, it's very fun actually to play with database. Unless you have a serious database, you have a serious database and then you deleted everything, it will be a problem to you. So collection of table, okay, collection of table under 1 DB, and then compromise of fields that define the entity. Entity is like the element, okay, yeah, it's element. Compromise the field, like I mentioned. Under DB we have table, under table we have column, or that column can be represented as a field, okay, that define the entity. And PK, primary key, has a unique value in each row of a table. This PK is already highlighted here. This one is unique. So if people say, what is the PK of this table? You cannot duplicate. You cannot, yeah, you cannot duplicate. You cannot the exact same name, exact same key, okay, in each row of a table. Foreign key, imported. Is it the term I use, imported, correct? Foreign key is primary key of another table. Yeah, we use that primary key of another table. It's not imported actually. I'm not sure what I say it is imported. Foreign key, that means we use that primary key of other table in our table. Yeah, it's like imported actually. So tables related to each other. Okay, so PK field of a table is a field of another table and a call of foreign key. This one is like mentioned up here. So the PK of a table, the primary key of a table is actually it is called foreign key. That means if you want to use the primary key in our table, we will call that primary key as a foreign table. So if foreign key, sorry. So that means when we are saying foreign key, when people say this is the foreign key, that you should know that foreign key is actually referring to other primary key of other table. Okay, relationship established by a foreign key of one table connecting to the primary key of another table. This one is the explanation just now. Okay, foreign key is actually primary key of another table. Okay, selecting the format of the storage database management system. Okay, software that creates and manipulate database. So here the terms I mentioned early on this lecture, I mentioned R, D, BMS, and DBMS. So R is actually stand for relational. DBMS is database management system. It's up here. So relational database management system is a DBMS for a relational database. So RDBMS or DBMS usually support referential integrity. So here the idea of ensuring the values linking the table together through the primary and foreign key are valid and correctly synchronized. Okay. So they are linking through using this key. Okay, primary key and foreign key. Foreign key is referring to the primary key of other table. Okay, are valid and correctly synchronized. Okay, here we have still in this one. So the class customer has an attribute which is customer ID. Okay, so the class order has an attribute customer ID that indicate that the customer who placed the order. Okay, customer ID. This one is our attribute. So this customer ID is referring to the customer who placed the order. Okay, so here, actually this one, customer ID. Save. Okay, this one, you should not be able to. That means if we don't have this attribute, okay, if we don't have this attribute, by right, of course, we cannot create an order for non-existing customer. So how do we know if he or she or they are existing customer is by referring to this customer ID. Okay, customer ID. So if we don't have this customer ID, of course they are non-existing order. Okay, delete a customer who has placed order unless there is a policy on what to do with those order. So we cannot delete a customer who has placed the order. Okay, unless under certain circumstances. Okay, and then change the customer ID value of a customer. Okay, not this one is very common actually. For some system, we cannot change whatever we already registered for the first time. Okay, again in banking. Okay, so we can change, for example, we can change our details, for example, what our income, our address, our email address, those stuff we can change. But um, for some for some data, here example, the customer ID, we cannot change this one. This one is fixed. If you have bank account, you cannot change this. I don't think the front end user see this. We have something that we call as SIF ID. That one is fixed. Your name cannot be changed. Your IC cannot be changed. Your address can be changed. Okay, we have this value that we cannot change. Whatever you do it under this customer ID, for example, under the SIF ID, like I mentioned, it will be always in the log. That means you can change anything, but your name will be always bind to the SIF ID. Here customer ID. Okay, so here is SQL. So SQL standard language for accessing data in table. This one is quite easy actually. If you play with data, this one is quite easy and fun. So SQL stand for structured query language. So I assume you guys are familiar with this. So here is the common. Here is the common. Here is the common. Okay, create, edit, and delete. Create, edit, and delete. Oh, here we have instruction. Create, edit, and delete. Create, that means we want to create, edit, we want to update, edit. Usually we will use update function. I'm not sure how you guys do, but for me, edit, usually I will use the update query and delete. Okay, delete table. Delete table and delete database is different thing. If you want to delete the table, for example, you have table A, this one you need to be very careful, okay? If you delete the table, that means the database, the DB is still there. But if you delete the DB, everything will be gone, okay? So, but there is a method actually on how to retrieve back the data that we already delete, rollback function. If you want to delete table only, be careful. Don't delete the whole database. It is very dangerous. Okay, add, edit, and delete data. Okay, add, edit, and delete data. Display data from more or one related tables. Display data computed from one or more related table. So here we have a query here. Query. I call it as a query. Is it query? Yeah, query. Query. So this one select all from this one. You guys know, right? This one is all. That means select all from customer. Customer is referring to our, okay, customer is our DB name, where this one is our column, right? Table. No, 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 no. No, no, no. This one is not DB name. This one is table name. Table name known as customer. Yeah, this one is not DB name. This one is table, and this one is column. So this one, this one is DB. I shouldn't explain. But this one is, if you see this one, that's mean all. They will display all the data under customer where the customer ID is 77. Okay, it's quite easy actually. So I think we should stop up to this patch for this week. Yeah, we will continue this. I think 15 more batch to go for this chapter. Okay. So is there any question? Oh yeah, I want to ask. Is there any student from this class who got bar from the exam? I don't think so, right? Because I didn't receive any notification. So since no question, I think, yeah, I don't think so in my class. I didn't receive any.